If you consider any electronic device, say this is a device, it's a device X, and this device has some sort of input and this device has some sort of output. So basically any electronic circuit, or any electronic device, maybe it's an audio amplifier or just a microphone, a computer, it's any filter circuit. This kind of devices always has some kind of input port. Input can be signal, voltage or current. Most of the time it's a voltage. And output is the output terminal, it's a output port. And output also can be a voltage or a current depending upon the requirement, but often I have seen most of the time output is a voltage. So let's take an example. Let's take an example of an amplifier. If you have seen audio amplifier, let's talk about audio amplifier in a very brief manner. Audio amplifier also has a very small input. It's a small changing input voltage. We call it a sinusoidal voltage, or sinusoidal AC small signal. Let's say it's a small signal voltage and it's a small signal, so let's say it's generated by V. It's an input and out V in, while the output is generated by V out or VO. So if you see in the microphone or even in audio amplifier, the input is very small while the output is almost more than 1,000 times better than the input. So we can say that output is some percentage, or it is multiplied by some number to the input. Now most of the time this quantity is called as gain, and it is represented as H by engineering term or in more technical manner. So VO is H times VI. Well, here it is not necessary that this H, or let's say it's a gain, is not always greater than 0 or greater than 1. So if you change this, VO divided by VI is equal to H, and H is called as transfer function. So today we are going to see a transfer function consisting of a resistor divider circuit. Now in this case I have talked about audio amplifier, which is a very complicated circuit. It can be a complicated circuit or a simple circuit, but since we are not talking about the amplifier, we will start with the simplest it's a simplest resistor divider circuit, or simplest voltage divider circuit. You can call it the simplest divider. So let's start talking about the simplest voltage divider circuit. Generally this voltage divider is consist of two resistors connected in the series. So this is a resistor R1, there is a node here, and this is a resistor R2. Other terminal of the resistor R2 is grounded, and here suppose we have applied 5 volts, and let's say this is input, and this is where we are going to measure a voltage across R2, which is output. VOP is the voltage at the output. We can write this circuit in a more basic manner as like this. This is R1, this is R2, this is ground. So let's say this is R1, again this is R2. Let's say this is output voltage VO, this is total is V in. Now generally if you see in any engineering convention or engineering notation, input voltage is written on the left side while output voltage is most of the time written on the right side. It's not necessary that it should be like this, but generally that's the case. And we have given a 5 volts and we want to find the voltage at the output, which is on the resistor R2. That's our goal of today. Now how we are going to find output voltage, right? Now we know that from the Ohm's law, V is equal to IR. So what the total, if we know the current flowing through R1 and R2, because whatever current flowing through R1 should flow through R2 the same current. So let's say this current is I, and if we know the value of this resistance R2, then we can find the voltage across R2. So V is equal to I into R. Now we don't have any expression, so this so this can be rearranged as VO is equal to total current I into R2, right? Now let's see how can we find I. So we know that I is equal to any voltage upon R. Now in this case voltage is V in, right, which is a 5 volt total voltage applied here. This is divided by total resistance of this ladder, which is R1 plus R2. It's a series combination of R1 plus R2. So we found the equation for I. Now let's put this equation in here. So I is equal to V in upon R1 plus R2 into this R2, and this gives us output voltage VO. So basically we found VO as voltage across the resistance R2 is that resistance value, which is R2, divided by R1 plus R2, which is total resistance in a series, multiplied by what's the input voltage with respect to ground, which is 5 volts here.